Hi, today we're going to talk about best practice for integration testing that really add value to business. Hi to everyone, I'm Denys, skilled at DashDevs, and during last 12 years of experience, I was working on the projects with different levels of complexity, which required regular manual testing, integration testing, and functional testing, planning, test automation, improvements of overall quality assurance process, and approach optimization. And today we're going to discuss the very interesting topic, the integration testing. So we will go through the items like integrated systems, the differences, the integration testing types, what is contract testing, integration testing on practice. That's the thing that we will discuss more in details, how to do integration testing, how you can plan it for product development. And we will discuss the case study from the past experience and some kind of future trends. Yeah. So what's the importance of integration testing for different systems? Let's take a look what kind of integrated systems can be. The first will be the systems where we have vertical and horizontal layers. So well-known fact that applications in its original architecture are divided into layers where the separation can be presented as a part of what users see, business logic, and data-related part. That is what we can see on the picture. Layering an application is useful for having a better overview of the application. It's clear what to expect in a specific layer. You have less complicated and non-transparent dependencies. This all applies for vertical and horizontal layers, but take effect in a different way. So vertical layering can be imagined like web UI, logic part, and with API, and data controlling layer responsible for data storing. It's not really the thing how many layers do you have. This depends on your needs, but you should have them and only expose access through a contract to the next upper layer. So, for example, there is a contract between application layer and business layer via API to properly interact between each other. And it already brings the first seeds for integration testing to be applied. Horizontal layering, it's more about building and using components or sometimes libraries, but above all, it is separating an application into different services. It's splitting an application into multiple domains. Then you have multiple services which are scalable and it's clear what they are doing. Of course, these services need to communicate between each other. This is mostly done over messages and or service endpoints. So there is no direct use of domain logic outside the domain from the service. In short, vertical layering is about application layers inside a microservice or monolith, at least inside a single executable application. Horizontal layering is about splitting an application into different domains or services. So let's talk about monoliths and microservice on the next slide. Monolith architecture is the name of a specific software program form. The model is constructed in a single block, otherwise known as a monolith, with all components tightly coupled into a single cohesive unit. A monolith computing network will use one code base and runtime environment to create a single tired application whenever how many vertical layers it has on board. A typical monolith architecture application has a front-end user interface, a server-side interface, and a database. If your needs are simple and you need a quick turnaround, monolith is the obvious choice. The microservice is a bit complicated way to organize your solution. Microservice architecture is an alternative approach to the development of application, also known simply as a microservices. This approach creates a larger application out of multiple modular services that communicate via APIs. But moreover, it also means an interaction between microservices on their level not only application API. For example, if you need to do a significant amount of real-time data streaming and processing, such as type streaming services, online banking, or e-commerce applications, are known for doing. Microservices are far more capable of handling this kind of data load than monolith applications. So let's talk about another way of how to make your product more complicated. That's the integration with third-party services. Okay. Let's take an example of microservices solution and imagine that this is the online banking application that should interact with third-party provider for credit scoring. So when the new customer onboarding, we should check if he or she is a good candidate for us to provide with the credit service. In case of third-party integration, we cannot control the development of such service, but we should support a grid contract for interaction between this service and our application. Moreover, whenever something is changed in our solution during its life cycle, the communication with third party should remain stable. This example adds more complexity to our solution. So we discussed the integrated systems and the ways how they can be designed and operating. Now we know how complex it can be and how much attention to details should be applied during the development and maintenance. Of course, in order to make such a solution to be working as all expect, the integration testing plays a very important role. However, we understand that it costs effort, but let's better talk how one non-properly tested service may bring impact on the business. Imagine that the service responsible for sending financial reports to some government institutions has one type of data and it has been failing during the months, making overall issue in accumulated data. For sure, it will take worse effect on company operations. Another example, it's online banking application that has SMS and push notification service that sends to the user temporary passcode. And it happened that another service that builds such a message sends wrong data that in the end makes it not possible to deliver the passcode to the user. In fact, it will block money transfer operations or even authorization to the application. Such case would definitely have bad impact on customer experience. That's why integration strategy plays an important role and should be carefully included into the overall testing strategy of the product. Now let's talk about integration testing types. So continue previous topic, let's define what is integration testing by itself. This type of testing examines how various software applications models interact and operate cohesively. At this stage, it begins to carefully examine the connections between each model to discover any possible problems resulting from a single unit. When the testing is complete, end-to-end testing is conducted to assess the application's functionality from start to finish. It considers the whole user journey from the initial to the final output to identify the issues when various units interact. Integration testing has different types, incremental and non-incremental, where the incremental type is also can be divided into top-down and bottom-up integrations. So let's talk about each approach in details. Top-down integration testing. So top-down testing employs a systematic approach to testing the software models from the top level down through the system hierarchy. The testing begins with the main model of the software and then proceeds to test the sub-models of the application. Its primary goal to ensure functionality between the higher-level models and their sub-models. As the testing procedure progresses through the hierarchy, model relationships are checked to ensure the software components operate as designed. Since high-level models undergo evaluation before lower-level ones, this technique enables the early discovery of high-level design failures. It aids in the early development phases detection of potential structural issues. Stubs can emulate lower-level models, so testing can start even before they're entirely constructed. This aids in improving the testing procedure and give the development team input more quickly, as early as possible. The top-down approach example, let's talk about this. The top-down testing starts by validating the primary model separately. It means the primary model is tested independently from the subordinate models without integration. The lower models are then integrated and tested one at a time once the main model has passed each of its independent tests. The flight search model is first integrated and tested with the primary model. The payment model is then integrated, tested, and finally the confirmation model. The process continues until all of the units are integrated and tested. Okay, so the next approach, the bottom-up integration testing. When performing bottom-up testing, lower-level models are tested first. It gradually moves to the high-level models, and so on, until all facets of the software have been thoroughly tested. This strategy is referred to as inductive reasoning. It's beneficial when incorporating pre-made or already existing components into the final product. It involves writing code for various models rather than focusing on stubs or mock objects. That's why its success rate is higher than other approaches. Furthermore, the execution time for the tests is frequently shorter than other traditional methodologies. This makes it simpler for the testers to conduct tests and construct the project to achieve the best results possible. And what about example? So the flight search, payment, and confirmation models are unit tested, ensuring they work as intended. First, the payment search flight models are combined and tested. This test verifies that customers can correctly complete all aspects of the booking procedure, including searching for flights and making payments. Then, search flight and confirmation models are combined to ensure that consumers receive confirmations of bookings after finishing the payment procedure. The process continues until all the models are tested. And also we have a Big Bang integration testing approach. So it entails compiling all software models into one structure and evaluating it as one unit. Individual models are not examined separately. Instead, they are combined and tested in a single process. It necessitates firm communicating between the development and testing teams to appropriately identify and solve any issues detected during the testing procedure. The Big Bang strategy can be quicker and less expensive than alternative approaches, as developers don't need incremental testing. This strategy could work for software systems with fairer and less intricate component relationships. However, it might be challenging to identify the precise model when flaws are discovered during the testing. Here are the examples. So all models, including primary, flight search, payment, and confirmation, are combined into one single system under the Big Bang technique. Several test cases are carried out to evaluate how well the system functions, interacts, and performs. Let's talk about contract testing. This is something specific and not really the integration testing. So integration testing is a kind of brute force. It needs all instances up and running in order to execute tests and to test apps, interactions, and functionality as is, with or without minimal mocking and stubbing. Integration tests need some preparation before they can be executed. Such an approach is the closest to what happens in production environment. The drawback of this kind of testing is extremely high weight of tests and long running time. Integration testing are both time and resource consuming. Contract testing has like recently grown in the popularity. It offers a completely different approach to test compatibility between models based on strict API definition. The main idea of contract testing is a contract or packed file, which all participants must follow. A packed file is a file that contains JSON serialized interactions, like requests or responses, or messages. For example, typical packed file of pack.ao framework defines consumer name, provider name, a collection of interactions or messages, a pack specification version. The diagrams above that we have on the slide show how different in coverage for integration and contract testing is. Integration testing covers the application in depth when coverage of contract testing is shallow. Even API layer is not fully covered. It's a feature of contracting testing to verify only interaction logic between apps and not apps itself. So from the diagram, we already see that contract testing requires less effort, but doesn't cover all application. When the contract tests are faster, less complex, less flaky, easier to maintain, and on the other hand, less independent than integration tests, but much more far from real apps behavior. So contract tests can be suggested to use every time when you have microservices architecture. It's worth maintaining that contract tests are not independent. We cannot have only one set of contract tests for all our needs, since contract tests are not about full code coverage. So we still need to use it in conjunction with other test sets, unit, functional, API tests, etc. So let's remember that contract tests are about complementing other types of testing, but not about replacing them. So the contract tests are applicable everywhere where the integration tests can be applied. And contract tests will help to keep integration tests at reasonable amount and can prevent from using those high weight tests exclusively. Okay, so let's answer the question: how properly plan integration testing for the product? And here is the steps. First of all, we should define the scope of integration testing. To kick off integration testing, we must first set the scope. This involves pinpointing which components or models of the application should be evaluated. Then we should determine how they will fit together with put a bunch of the tests. Next step is to define the approach for the testing. As we already discussed a different approach to integration testing, the best one in our case should be chosen including the complexity of the system, available time, and resources. Then we should identify test scenarios. To progress to the next phase, we should recognize and execute all feasible test scenarios. These tests must cover every collaboration like between the individual components of the application. And after that, we should select the tools that we can use for the integration testing that allow us to prepare the mock, stubs, generate test data, whatever. After the test scenarios have been outlined, we should generate the appropriate data that will employ it to run these tests. And this test data should include all potential input conditions and must contain both valid and invalid information. And after that, finally, we can start creating the test cases. So we should develop test cases for each scenario using the given data and scenarios. Establish clear inputs, expected outcomes, and pass-fail criteria in every case. And we should make sure that we have properly outlined all components to ensure the successful completion of tests. Next, it's time to get our testing environment ready. So this consists of building a standalone setting for examining, customizing the application and infrastructural constitution parts, and ultimately deploying the app in the test space. So after the test environment is up and ready, we can start the execution of the test cases. It's important to follow the same order of the identified test scenarios in step 2 when running each test. Next, we should install, configure the monitoring tools. So we should analyze and assess the test results with keen scrutiny. And then after that, we should sort the results based on their gravity and how they influence the application's performance. And finally, we should prepare the report and track issues. This guarantees that all concerns are addressed before the application is moved to production. Let's look on one of the projects that we have developed and is very good for integration testing strategy analysis. It's a sophisticated web-based system for one of well-known recruitment agencies in German market. Over a multi-year effort, we designed this platform to streamline internal operations for their large recruitment team, management, finance, and consultants. The intuitive user interface we crafted allowed us for seamless job vacancy management and efficient candidate processing. Our solution included several key integrations. It's a vacancies portal, an advanced finance system, a CV parsing solution, and legacy back-office system. Additionally, we connected various social networks to enhance recruitment efforts and expand candidate outreach. So again, let's list again the integrations. Vacancy portal, social networks, CV parsing solution, finance system, and legacy back-office system that is actually custom one. We had to incorporate different integration approaches to meet strict deadlines with the high quality. The most challenging part was with the back-office system, as the development also should have been done on its side from scratch to have proper integration. So we decided to follow the hybrid approach in our strategy based on scope and requirements for each integration part. For the components of the recruitment system in our microservice architecture, we decided to use the bottom-up approach that is better applicable for the development of new application and provides high-quality outputs. However, it requires more time effort. For the vacancy portal, social networks, CV parsing, and finance solution, we didn't require development on their side, so we decided to go with Big Bang approach that helped us evaluate the system as one unit and perform end-to-end system tests. As for back-office system, we choose contract testing approach. It doesn't require all variations of tests to be executed and can save a lot of time. However, it may lead to potential issues later. So from this project, we learned that the general different approach for the testing based on types of systems, development efforts, time, and deadline were chosen ideally, especially contract testing for both systems under development with strict deadlines. It saved us a lot of time. However, we found quite enough bugs during user acceptance testing phase, but they were fixed in a timely manner, so the deadline was not postponed. It was like a win-win solution in our case. Okay, so what about future trends in software integration? A game changer in software integrations is the use of artificial intelligence for sure, and machine learning algorithms. These advanced technologies allow for systems to process and learn from large sets of data. This leads to operations that are smarter and significantly more efficient. For example, artificial intelligence algorithms have the capability to predict system failures or the optimization of resources allocation. Meanwhile, machine learning tools can adapt to and improve process based on data patterns. Next one is IoT, the Internet of Things, is dramatically extending the horizons of software integration. IoT connects countless devices and sensors to enable the collection and analysis of large amount of data from various sources. This allows for deeper insights and will enable enterprises to make more informed decisions. More comprehensive and sophisticated analysis is made possible with different data sources integration. The confluence of AI, machine learning, and IoT is thus forming a new era in software integration. And this era is marked by interconnected, intelligent, and evolving systems. For software engineers, a commitment to lifelong learning is required. This active engagement with the latest trends ensures that they adapt to the rapid evolution in software integration. This involves going beyond traditional learning methods. Engaging in open source projects can gain hands-on experience with new technologies and integration techniques. Participation in hackathons or coding challenges can also help in problem-solving skills to apply to real-world scenarios. In addition to this, contributing to technical blogs or publishing research can deepen understanding and help software engineers establish themselves as thought leaders in discipline. Such a multi-phased approach to engagement ensures that the software engineers remain adapted in this ever-changing software integration environment. So we've discussed today the complexities of different integrated solutions for the testing, the importance of integration testing for products and business, the balance between effort and value for customer experience and product development. Also, we learned the significance of integration testing strategy and the integration of third-party vendors and services and how it can be done on practice. The significance of software integration in today's developing business environment can be underrated. From the importance of strategic planning, selecting the right tools, and approach to ensuring security and compliance. We've underlined the importance of software integration for enterprise efficiency and innovation. The keys to maintaining efficiency in integrating systems are continuous monitoring, testing, and knowledge sharing. Software engineers must stay informed and adaptable as emerging technologies like AI, machine learning, and IoT shape of the future. So if you have any questions, please contact us by email or visit our website, even LinkedIn, or just call. Thank you.